Physics is all about understanding the world, the universe around us. And to do this effectively, we need to be able to take measurements and to do it accurately and precisely. Now, we'll learn more about what those terms mean fully later on. But for now, let's start by looking at how to get those accurate results. And we're going to start off by looking at time. Time is a good place to start because it's so commonly important and has a lot to it. A simple experiment might tell you, drop a ball from a height of 30 centimeters and record the time. Now imagine the experiment in your head, or even try dropping something and record the time. What would you write down? Now for me, looking up at the wall, I'd record 10:23 a.m. That's the time. Clearly the instructions were a bit rubbish. What we really want to do is record the time taken for the object to fall. So there's lesson number 1. Be specific with language. A variable has 2 elements. Here, those elements are time taken and object falling. Another thing about time is it can be very long or very short, and the equipment used changes depending on the length of time. A calendar might be okay for events that take many weeks, but usually we're going to use a stopwatch or a stop clock to measure the number of seconds. This stopwatch reads 34 seconds and 15 hundredths of a second. That's 34.15 seconds. You've probably played around with a stopwatch to see how short a time you can get. Anything below 0.20 seconds, 20 hundredths of a second, is pretty good. Now that should tell you something about the limitation of human reaction time. It's a good approximation to say that you cannot reliably measure better than 20 hundredths of a second. To make life easier, we bring that down to 10 hundredths or 1/10 of a second. 0.1 seconds. 1 decimal place. That's easy to remember, but why is it important? Well, let's say you are timing something that is pretty quick. That object you dropped 30 centimeters. It probably took about 0.2 seconds. How well do you think you can trust your answer? Now, it may be okay, but if you do it again, I bet your reading is a bit different. There's an error in your measurement, human error. It could be as much as 0.1 seconds, and the total time was actually 0.3 seconds. That would make it a 33% error. Massive. Now, the interesting thing is that if you use the same method to time how long it takes for a kettle to boil, you would get the same error, 0.1 seconds. But the time would be long, 3 minutes maybe. So 0.1 divided by 3, we need to convert to seconds first. So 3 minutes is 3 times 60 equals 180 seconds. So 0.1 divided by 180 times 100% equals 0.06%. That's tiny. Usually we'll be somewhere in between, and getting under 10% error is considered fine. It's good. We consider it to be within the limits of experimental accuracy. That's a good term to use in GCSE. Now, you don't need to actually calculate the error like we did here until A level. Back to the measurement though. It's too quick for us to measure, so what can we do? Well, we could change the apparatus, use a light gate or a strobe to freeze the motion, or a video with slow motion playback. If we stick to using the stopwatch though, we could make the time longer so that the error gets smaller. The way to do that is time multiple events. For dropping an object 30 centimeters, we could change it to 120 centimeters, so the distance is 4 times longer. That will get us to a decent amount of time. There you have the basics of measurement. Be clear about what it is you are measuring, and there's always going to be some error. The goal is to make the measurement large so that the error becomes less significant.